Okay, so we are on day 3 of Unit 1. We are on exploring angle pairs. And so you should have the Unit 1 Lesson 3 notes out. So we're going to talk about the types of angle pairs. Yesterday we focused on segment angle addition. So today we're going to focus on understanding how angles relate to each other. So again, a highlighter might be helpful, or if you have a way to underline specific vocab words, that'd also be great. So the first word that we want to talk about is adjacent. Adjacent simply means that if I have an angle here and I build a second angle off of it, angle 1 and angle 2 are said to be adjacent. So angle 1 and angle 2 are adjacent because they share a common side. So this ray in the middle is the common side. They have a common vertex. So this point right here is the common vertex. And they're next to each other. Okay, they're not, one's not inside of 2. You know, if I were to name the big angle and name it angle 3, 1 is not adjacent to 3. 1 is part of 3. So we got to make sure like they're next to each other. Okay. All right. Our next word is vertical. Vertical angles are 2 angles whose sides are opposite rays. So if I make a line and another line, this is an opposite ray, this is an opposite ray. So if I name these angles 1 and 2, angle 1 and 2 are vertical to each other. Now notice I did it this way because I want you to understand that vertical has nothing to do with up and down. Vertical has to do with back to back. So if I turn this picture, angle 1 and 2 are still vertical to each other because they share a vertex and they go opposite directions. Now, the cool thing about vertical angles is that they are congruent. All right. Complementary angles. 2 angles whose measure have a sum of 90 degrees. They are the complement of each other. So again, this is pretty straightforward. If I draw a right angle and I break it up into 2 parts, angle 1 and angle 2 are complementary. Likewise, we have supplementary angles. 2 angles whose measure have a sum of 180 degrees, and they're called the supplement of each other. So if I have a straight line, and it doesn't matter how I split it, but if that straight line breaks up into 2 angles, then those 2 angles are supplementary. So I have 6 questions that state simply true or false. You have a set of angles here. There are 6. We'll say 1, 2, 3, 4. I'm sorry, there are 5. But there also are bigger angles, like, you know, BFD is a bigger one, and AFC is a bigger one, 4 and 5 put together. We're going to talk about this, and we're going to talk about this too right now. This is a straight line. There are 100 degrees, 80 degrees in a straight line. So if this angle is 118, just like we learned yesterday, angle 3 is 62 degrees. If angle 3 is 62 degrees and angle 4 is 28, angle 5 is 90 degrees because this is a straight line as well. And so now that you know that, pause the video, take a couple minutes, and answer these questions. Okay, so here's the answers to those 6 questions. BFD and CFD are adjacent. That's not true because if you notice, BFD is a right angle of which CFD is a part. AFB and EFD are vertical, that's also false because AFB and EFD, while they share one common side, they don't share two. 3, that's true because they're equal 90 when put together. 4, that's true because not only are they congruent, but they do share two common lines. Number 5 is false because their total is 146. We needed a total of 180. And same thing for 6. It's false because their total is 208 and we were looking for 180. A couple of things that you can conclude from an unmarked diagram. If two angles are adjacent, if two angles are adjacent and supplementary, and if two angles are vertical. You cannot conclude congruency, right angles, or complementary. So your check for when you bring the notes in tomorrow is, I want to see you pick 3 things that are true about this diagram. And I want you to put them right here in this area. And this will be our starting point for discussion tomorrow in class. Alright, linear pair. Basically, linear pair means the same thing as supplementary. So when we're looking for a linear pair, we are looking for a pair of adjacent angles whose non-common sides are a straight line. Or more specifically, opposite rays. So if two angles form a linear pair, then they are supplementary. So when you see the word linear pair from now on, and I don't know if you need to box this, highlight it, whatever, when you see the word linear pair, you should be looking for 2 supplementary angles that form a straight line. Okay? Alright. Now, when we have an angle, and we talked about this yesterday, we can bisect it. A ray that divides an angle into 2 congruent angles is an angle bisector. So ray AY in this picture is an angle bisector. Now, all of this goes into play, and we can use this information to find angle measures. So I have this picture. Obviously, this is a right angle. If I had this picture, and I told you the same thing, well, obviously this is 180 degrees, so if I had like 6x and 3x, we could solve. In both of these cases, what do we have to do? You have to add the 2 pieces that are inside and set them equal to something. In this case, what are we setting them equal to? Well, we're going to set them equal to 90. In this case, what are we setting them equal to? We're going to set them equal to 180. But just like with the last 2 sections, once you find the value of x, that's not enough. You still need to plug it back in. So this is 30 degrees. This is 60 degrees. This is 120 degrees. This is 60 degrees. Where it gets complicated is they'll sometimes throw algebra in. But what I'm going to tell you is, and I kind of touched on it yesterday, you're either going to be able to set 2 algebra equations equal to each other, but if that doesn't make sense, you're going to have to add them together. In this case, because of the congruency marker, we can set the 2 algebra equations equal to each other. Okay? Once we do that, we subtract 3x, add 14, we get x is equal to 11. Then once I plug this back in, we get that this angle is 30. Well, if this angle is 30, how much should this angle be? It should also be 30. And when we plug it back in, we know that's true. 4 times 11 minus 14 is 30. Draw a picture. It says these 2 angles are a linear pair. Let's break it up. EFG. 2n plus 21. GFH. 4n plus 15. What do you think I have to do with these 2 pieces of information? Can I set them equal to each other? No. Since I can't set them equal to each other, what do I have to do with the two things? Add them together. So if I add them together, I get 6n plus 36. But what are they equal to? Well, it's a linear pair. And I said think supplementary whenever you see that. That means they're equal to 180 degrees. We solve for n. And then we plug in back in. So this ends up being equal to 111. And this one ends up equaling 69. 69 plus 111 is 180. We're good to go. That finishes up the work for this section of the notes. I suggest you look back over, especially where we focused on the mathematics side of adding algebra and making sure you understand that you have two options. You can either add them together or set them equal. In the workbook, you're going to be going to page 19. You're going to be doing 1 through 14, and then on page 21, 1 through 6. And the advanced problems are on page 20, 17 through 24. Remember, the key is create a picture. If you're able to go quickly through this and get it done, then you'll be able to get started on the next lesson. And if you're one of those that's moving fast, maybe we'll get you into a project in this unit. But it'll be kind of like a fun little extra thing that you get to do in lieu of more work. So show me what you know, impress me, and you'll get to do some fun stuff with the projects. So, all right. If you have any questions, make sure you bring them to class, and we will get to work on these.